Okay, let us proceed to the example 2 of this thevenin equivalent circuit. So we have 90-volt source, and then a 30 ohm resistance, a 60 ohm resistance, another 10 ohm resistance, and then a positive Vx negative, and then we have our 6 ampere current source, that is, take note, that is an independent source. Then we have our 30 ohm resistor and a 20 ohm resistor. And then we have our 40 volt source. Okay. So how we will solve this? We will solve for the value of our Vx. Solve for Vx. And after solving for Vx, write the diagram of Norton and thevenin. So as I have said, I prefer to use thevenin every time because your Norton and thevenin, they are the same. Uh, it's better to use thevenin in my opinion, and then you will just transform it into its equivalent Norton circuit. Basically because your Norton or your Norton is just the source transformation of your thevenin. Okay? So let us proceed. So solve for Vx is that we will take out your Vx. So tatanggalin natin yung Vx mo. So we'll have a circuit which is positive, negative, 90 volts. We have our 30 ohm resistor, another 60 ohm resistor, this is the terminals of your Vx, and this will be your 6 ampere current source. Okay, and then this will be your 30 ohm resistor, another 20 ohm resistor, and then your independent voltage source 40 volts. Okay, this will be your positive negative Vx, positive negative Vx, which is your 10 ohm. That will be our terminal A and B. Okay, so let us write the diagram. So this will be my diagram. So I will have my positive negative VTH, and then also I will have my RL or my RTH, then my RL, which is your 10 ohm. So hindi natin tatanggalin yung yung sign niya. Okay, which is 10 ohm. Okay, so let us solve for RTH. Solving for RTH, so we will have a circuit diagram equal to a shorted 90 ohm, a 30 ohm resistor, another 60 ohm resistor, and then your AB, and an open 6 ampere current source. And a 30 ohm resistor in parallel with it, a 20 ohm resistor in series with a shorted 40 ohm. Okay, so solving for RAB or your RTH, so we will have the series combination. Take note that it is the series combination of your parallel combination of your 30 in parallel with 60 plus 30 in parallel with 20. So if you cannot visualize it, I will write it. Okay, so you'll have, since these two nodes are in the same terminal or interconnected with each other, so therefore I may say that they are in parallel, and your 20 and 30 is in parallel also. So therefore we will have a combination of this one. Okay, this is your AB. Okay. This will be the parallel combination of your 30 and 60, and the parallel combination of your 30 and 20. Okay, so therefore we will have an RTH equal to 1 over 30 raised to negative 1 plus 60 raised to negative 1. We have 20 ohm plus 1 all over 30 raised to negative 1 plus 20 raised to negative 1. We have 12 ohm, which is equal to 32 ohm. That is our RTH. So how will we solve for our Vx or Vth? Okay, let us focus into this figure. Okay, you see that this is already open, which means that there will be no current passing through this circuit. Pwede na lang dyan is yung voltage of your 60 ohm, and then the voltage of your 6 ampere, which is parallel with your 30 ohm. V30 and V60. Actually, the voltage of your 60 ohm can be solved by voltage division. Okay? Kasi wala na to eh. Wala nang connection tong dalawa because we already tinanggal natin yung 10 ohm. And then, therefore, kanya-kanya silang circuit. We have two circuits. We have the circuit for a voltage division and a circuit for either nodal analysis or source transformation. So, how will you do it? For source transformation or nodal analysis, I will prefer to use my nodal analysis at node A and having a datum at point B. Okay? So, let's solve for V30. Solving for V30, we'll have a nodal analysis at 6 ampere. So, we have going to the node is your 6 ampere kasi wala nang connection to. So, therefore, itong 6 ampere na to, pwede na siyang dumiretso dito. Right? So, we have 6 ampere. Okay? And then, the current going to your 30 ohm or your I30. So, negative yan, it is going out the node. Plus the current by 40 ohm to your VA or your V30. So, we have plus I40A. Means 40 to node A. So, our I40A, 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 40 to node A. So, Our I40A is equal to 40, your higher potential, minus VA or your V30. But V30, because they are in parallel, so pwede kong sabihin na that is also your V30 divided by 20 ohm. Okay? And then your I30 is equal to V30 all over 30 ohm. Okay? So therefore, take note that it must be equal to 0. Okay? Because it is the conservation of charges. So upon knowing this equation, so I may substitute it. Your 6 ampere minus I30, which is V30 over 30, plus 40 minus V30 over 20 equals 0. Solving for V30, we'll have a value equal to 6 minus V30 over 30 minus V30 over 20 plus 40 divided by 20 is equal to 2, which is equal to 0. So therefore, transferring your negative V30 and negative V20, will have 1 over 30 plus 1 over 20, we have 1 over 12. V30 over 12, which is equal to 6 plus 2 ohms, which is equal to 8 ohms. So therefore, our V30 is equal to 96 volts. Next is we will solve for your 60. So solving for V60, ito na lang sa tabi niya. So your V60 is just equal to, using VDT or your voltage division theorem. So we have 90, V60 is equal to 90 multiplied by 60 divided by 30 plus 60, so we have 60. Upon knowing this one, your V60 and your V30, which is an essential part in solving your Vx, we will make a mesh or a loop with this. So we will go into your V6Bx, lalampasan natin yung 6 ohm, and then we will go to your V30, then we will go back to your V60. Okay? So KVL at the red loop, so we'll have a negative V60 kasi pumasok sa negative part ng V60 nyo, plus our VAB or your VTH, plus our V30 equals 0. Ang tanong, yan na ba yung Vx natin? Not yet. That is not yet your Vx. Okay? So your VAB therefore is equal to negative V30 plus V60, which is basically equal to negative 96. So positive, negative V30, so negative 96 plus 60 equals our VAB. So we have negative 36 VAB, which is equal to our VTH. Okay. So we will have a value of your VTH. Your VTH is equal to negative 36. So getting the Norton equivalent is that you will have a current equal to, so since negative yan, pababa siya. Okay? Yan. So negative 36 over our RTH, which is equal to 32. Okay? And then a parallel combination of your 32 ohm, which is your RN, and then your 10 ohm resistance. This is your Norton equivalent. So solving for VTH, you may use your VDT. So we have negative 36 Vx, solving for Vx. Vx is just equal to voltage division. So we have negative 36 multiplied by 10 ohm all over 32 plus 10. You may also use your Ohm's law, wherein you will get the current and then you will multiply it to the voltage or to the resistor 10 ohm to get the voltage Vx. So we have negative 36 times 10 all over 32 plus 10. So we have a value equal to negative 8.571 volts. This is the value of your Vx. Okay? That is our example 2.